Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is surds or radical, as you may call it. If you are in senior college, preparing for WAEC, for NECO, for GC, for NAMTEC, for JAMB, or any other external exams into high school, this topic, this lesson is for you. You are in the right place. PetakusEduCom community. Lesson 4, division of surds and conjugates of binomial surds. So we have two in one lesson. So let's see the meaning of the two concepts. Before that, for updates, follow PetakusEduCom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, your colleagues, your classmates. Facebook at fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom, WhatsApp through this telephone mobile number or mobile telephone number. Okay, in all of these platforms you get updated from time to time about what is happening at PetakusEduCom community, where you have access to quality, unlimited and simplified mathematics teachings in series. So the first part of this lesson is division of surds. When a surd occurs as the denominator of a fraction, the best thing to do is to rationalize the denominator. To rationalize means to turn an irrational number of the denominator of a fraction into a rational number. That term that you cannot get its square root that is in the denominator, you try to remove it. That term is referred to as irrational number. So you try to change it to rational number, and the process of doing that is called rationalizing the denominator. To do that, you multiply both the numerator and denominator by the surd, which makes the denominator irrational. That's all you do. That irrational number in the denominator, you use it to multiply both numerator and denominator. That will change or turn the irrational number in the denominator to rational number. So let's see some examples to that effect. Example 30. So you are asked to simplify 3 root 2 divided by root 10. So where do you look at denominator? Root 10 is an irrational number, and we wish to remove it or change it to rational number before we can divide successfully and easily. So to do that, the irrational number root 10 is used to multiply both numerator and denominator in this form. See that? So you have 3 root 2 times root 10. Remember, different surds can be multiplied from lesson 3. That is 3 root 20. Then root 10 times root 10. If you multiply the same surd, what is the outcome? The number without the square root. In other words, root 10 times root 10 is root 100, and root 100 is 10. you have turned the irrational number to a rational number. You can express root 20 in basic form because there's a factor of 20 that is a perfect square. So you have 4 times 5. 4 times 5, root of 4 is 2, then you have root 5 times 3. So you have, okay, but before we multiply, we are seeing that this 2 can divide this 10, so you are left with 3 root 5 all over 5. You have removed the irrational number or changed it to rational number. That is how surds are being divided. Example 31, you have 9 over root 18. The same thing. You look at the denominator, the number there is root 18 that you must turn to a rational number. The only way out is to use root 18 to multiply both numerator and denominator in this form. So you have 9 times root 18. You can express root 18 as 9 times 2. Then root 18 times root 18 is 18. Before you do that, first 9 can divide root 18, can divide 18. So you have 2 left in the denominator. Meanwhile, root of 9 is 3 times root 2. So you have 3 root 2 all over 2. Mind you, this 2 here cannot divide this 2 because this 2 is under square root sign. It is an irrational number, while 2 is a rational number. So 2 cannot divide root 2. So the answer is expressed the way it is, 3 root 2 over 2. Are you following? Example 32. So before you think of division, you need to simplify this expression to be in a single form, that is a single fraction. That is what I mean. Okay, looking at this, you can express this in a basic form, that is 2 root 2. To have a balanced fraction, you write this all over 1 in this form. So you find the LCM. Anytime fractions are being added or subtracted, you must find the LCM of the denominators. So the LCM of 1 root 2, 2 root 2 is 2 root 2. You write down the LCM by the rule of solving fractions under addition and subtraction. You divide the LCM by each denominator and your answer times the corresponding numerator. Okay, let's see that. If you divide 2 root 2 by 1, you have 2 root 2 multiplied by root 2. So first, this 2 here is the first 2 now. Root 2 times root 2 is root 4, that is 2. So you have 2 times 2. You see that? If you divide root 2 by root 2, you have 2. So 2 times this one, you have this 2. Divide root 2 by itself is 1. 1 times 1, you have 1. So you have 4 plus 2 minus 5 over 2 root 2. That is the step here. When you add and subtract, you have 5 over 2 root 2. So the denominator contains an irrational number that you need to turn to a rational number. To do that, you use the rational number that is root 2 alone to multiply both numerator and denominator in this form. So 5 times root 2, you have 5 root 2. Then 2 is there, that is the constant now. Before root 2 multiplies root 2, that will give you 2. You know, root 2 times root 2 is root 4, and root 4 is 2. So 2 times 2, you have 4. finally you have 5 root 2 over 4 as a result when that expression is simplified. Example 33. Simplify this. Before we try to rationalize, you have to carry out the subtraction. Looking at 27 is a single form when expressed in basic form following lesson 1. You have 3 root 3. So you have 2 over 3 root 3 minus 2 over root 3. Fractions subtraction demands that you find the LCM of the denominator as the first approach. That is 3 root 3 because root 3 is common to both sides. So you have 3 root 3. You write down the LCM 3 root 3. You divide 3 root 3 by 3 root 3. You have 1. 1 times 2. You have 2. You divide 3 root 3 by this root 3. Now you have 3 remaining times this 2. You have 6. So 2 minus 6 is minus 4 over 3 root 3. We have an irrational number in the denominator that must be turned to irrational number. To achieve that, you use root 3 to multiply both numerator and denominator in this form. So minus 4 times root 3, you have minus 4 root 3. This 3 here is a constant. It will come first. Then root 3 times root 3 is root 9, and root 9 is 3. So finally you have minus 4 root 3 over 3 times 3 is 9. No other common factor can divide. Okay? Example 34. You have square root of 3 over 24 times square root of 8 over 26. First, let's try to reduce. You can divide 3 and 24 by 3. When you reduce, you have 1 over 8. If you reduce 8 over 26, that is, if you divide both numbers, you have 4 over 13. The basic rule of surd, we said that you can split it. So you can split the first one as root 1 over root 8. The second one root 4 over root 13. And root 1 is 1 all over root 8. Root 4 is 2 over root 13. We can express 8 in basic form because 8 has a factor of 4. It's a perfect square. Square of 4 is 2. So you have 2 root 2. Then times 2 over root 13. These 2 can simply divide these 2. When you multiply the remaining terms, you have 1 over root 26. That is root 2 times root 13 is root 26. This root 26 is an irrational number. To turn it to a rational number, you use to multiply both numerator and denominator in this form. So 1 times root 26, you have root 26, then root 26 times root 26, that is simply 26. 26. Did you get that? Okay. Example 35. We have 10 over root 32 over root 32. Okay? If you wish to express 32 in basic form, rationalize is the same thing as rationalizing directly is quicker. Okay? To turn root 32 to rational number, you use it to multiply both numerator and denominator. So 10 times root 32. So you can express 32 as 16 times 2. Then root 32 times root 32 is simply 32. Square root of 16 is 4. So you have 4. while this 5 and 16 will reduce 10 and 32 using 2 to divide. So you have 5 and 16. Before square root of 16 is 4 times root 2. And again, 4 can reduce 16, and you have 5 root 2 over 4. 5 root 2 over 4. Example 36, we have m root n over root n. Whether the numerator and denominator are irrational, the one you pay attention to, the one you consider is the irrational number in the denominator, that is root n, and you turn it to a rational number, that is rationalizing now. Okay, to do that you multiply both numerator and denominator by m, by root m. So you have root m over root m in this form, then multiply m root n times root m. Because different surds can be multiplied, you have m outside first. Root n times root m is root mn. Then root m times root m is m. By the time m cancel m, you have root m n remaining as the final answer. Okay, so let's introduce rationalization of surd by conjugate. Rationalization of surd by conjugate. If you look at all we have done so far in this lesson, the surd are single surd. At least simple, just one. Maybe you have root 2, so just like that. But in this concept, when you have two surds, refers to as binomial surd. For you to rationalize, you pass through conjugate. Then let's understand what is conjugate. All right, but before then, a binomial surd is a surd of the form a plus root b. Binomial means two-term expression. So binomial surd, they are surd that contains two terms. Another one is root a plus root b. It's binomial surd. You have a root b minus b root a. So all these expressions are referred to as binomial surd. Two terms expression are binomial terms or binomial expression. Now that it contains surd, it becomes binomial surd. A binomial surd always has two terms. I've said that before. To rationalize a binomial surd, we use the idea of difference of two squares. For instance, to rationalize root a plus root b, we multiply it by its conjugate. You see where it comes in now. So the conjugate of root a plus root b is simply root a minus root b. So conjugate is simply change in sign. The sign that connects root a and b is positive. When that sign changes to negative, it becomes its conjugate. And when you multiply root a plus root b by root a minus root b, that is the same thing as difference of two squares that you can express in this form. So therefore, root a plus root b and root a minus root b are said to be conjugate of one another. In other words, if you have root a minus root b first, its conjugate becomes root a plus root b. Okay? The product of a surd and its conjugate will give a real number. That is a number without a square root sign. You must know that. The simple truth is that To obtain the conjugate of binomial sort, simply change the sign plus minus that joins the two terms together to minus. In other words, you change plus to minus and you change minus to plus. Alright, so let's put all of these to divide the complex sort. Alright, example 37. You can see it now. Root 5 plus root 3 divide by root 5 minus root 3. So sometimes we refer to binomial sort as complex or composite sort. So to do this directly or to rationalize, we want to turn root 5 minus root 3 to a real number. So you must take the conjugate of the denominator. Denominator is root 5 minus root 3. Each conjugate becomes root 5 plus root 3. The rule remains the same. You use the conjugate to multiply both the numerator and denominator. So this is the number itself times its conjugate in this form now. So the same rule, the first term here multiplies first term, second term. First term, second term. When you are done, second term multiply first term and second term. Same thing happens to both numerator and denominator. Okay, so the first term here, root 5 times root 5 is root 25, and that is root 5 times root 5 here. That will give you 5 in return. The same root 5 times root 3, you have root 15. Now you use the second term, root 3 times root 5, you have root 15. The second term, root 3 times root 3, that is root 9, and root 9 is equal to 3. Denominator, you have root 5 times root 5, that is 5. You know why now. Then root 5 times plus root 3, that is plus root 15. The second term is minus root 3 times root 5, that is minus root 15. Minus root 3 times plus root 3 is minus root 9, that is minus root 3. So you add the constant and the like terms together. So 5 plus 3, that is 8. Root 15 plus root 15 is 2 root 15. In the denominator, plus root 15 minus root 15 is 0. So you are left with 5 minus 3. Okay, so you have 8 plus 2 root 15. 5 minus 3 is 2. Now if you look at the two terms, the numerator, you can factor out 2. Factor out 2, that is 2 is outside. If you use that 2, you factor out to divide 8, you have 4. To divide 2 is 15, you are left with 15 over 2. By the time 2 will take care of 2, you are left with 4 plus root 15. So you now have a real number. Something can be like this, or it can be in fractional form when there is no term that can remove the denominator. So this is how conjugate is used to simplify complex sort. Okay, end of lesson 4. Thanks for watching and learning with PetakusEduCom community. Don't forget, watch out for more from the voice of Petakus. For inquiries and questions, use the comment section. For the complete package, of this topic, lesson 1 to 6 for offline usage, you can contact the Voice of Pentecost via this WhatsApp number or through this email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not saved, your life will be in crisis. To avoid that, you need to give your life to the one that can save you. That is the Lord Jesus Christ, and confess him daily as your Lord and personal Savior. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hand and your brain to work, and the Lord will bless you. And also, goodbye for now.